Welcome to Fantastic Vision. Please subscribe us before you watch today's video. The morning mist in Eindhoven, the Netherlands, has not yet dissipated, and the ASML factory has already sounded the mechanical roar. In March 2025, on the assembly line of this lithography machine empire, 600 DUV lithography machines are lined up like silver-gray behemoths ready to go. This number is exactly 3 times the chip production capacity of China 5 years ago. When ASML announced that it would pour this batch of precision instruments into the Chinese market, the seismic waves of the global semiconductor map were radiating from the wafer factory of Yangtze Memory to Silicon Valley. Behind this seemingly commercial game, it is actually the life and death speed of the generational change of lithography machine technology. ASML's latest high-NA EUV lithography machine is spitting out 2 nanometers chips in Intel's workshop, and the speed of 200 wafers per hour pushes Moore's law to the physical limit. But what shocked the industry more than this is that Chinese engineers used multiple exposure technology to carve out a circuit equivalent to 7 nanometers on a 1980 Di lithography machine. This homemade steelmaking initiative made the EUV lithography machine worth $120 million suddenly no longer indispensable. Just as digital cameras overturned Kodak film, China is using process innovation to dismantle ASML's technological moat. ASML's anxiety is hidden in the folds of its financial reports. The gross profit margin of immersion DUV lithography machines in China is as high as 58%, far exceeding the global average, which explains why its CEO Peter Winnink said the shocking words, "Losing the Chinese market means losing the future." When Nikon launched a 30% cheaper competitor, nanoimprint technology reduced the cost of chip manufacturing to 1/10 of EUV, and ASML's 600 DUVs were more like a clearance carnival before the technology generation switch. These precision instruments that are about to set off are not only harvesters of commercial interests, but also a delaying tactic to slow down China's independent innovation. The evolution speed of China's chip industry is rewriting the rules of the game. The Kirin 9020 chip equipped with Huawei Mate 70 uses a 14 nanometers process to run 7 nanometers performance, proving that process numbers are just footnotes to business narratives. SMIC's 28 nanometers production capacity has soared 400% in 3 years, and the scale advantage of mature processes has allowed American companies such as Texas Instruments to turn to the Russian market. This, surrounding the city with the countryside technology route, is just like the history of the Japanese auto industry using fuel-efficient cars to counterattack American muscle cars. The irony of geopolitics is that blockades often give birth to the most dangerous opponents. When the US ban tried to freeze the flow of EUV lithography machines to China, it unexpectedly activated the alternative plan of this Oriental giant. Shanghai Microelectronics' 28 nanometers lithography machine has entered mass production and debugging, and the synchrotron radiation light source lithography technology developed by the Chinese Academy of Sciences, skips the optical lens and reaches 5 nanometers accuracy. ASML's 600 DUVs are more like the last wait before the technological balance tilts, just like Kodak's last film promotion before the advent of the digital age. In this century-long game, ASML's decision reveals a shrewd business sense. Its latest financial report shows that the proportion of prepaid accounts from Chinese customers has soared from 18% to 37%. These real money promises are more convincing than any political promises. When Intel used high-NA EUV lithography machines to impact the 2 nanometers process, ASML tilted its production capacity toward DUV. This strategy of eating from the bowl and looking at the pot is precisely to see the golden window period for China's mature process expansion. In the next 5 years, 60% of the world's new chip production capacity will be concentrated in processes above 28 nanometers. The Yangtze River in the twilight is emitting a metallic luster, and SMIC's newly built wafer fab is swallowing ASML's DUV lithography machines. The deep ultraviolet light projected by these precision instruments not only etches circuits on silicon wafers, but also develops a new order on historical films when Chinese engineers use multiple exposure technology to break through the physical limits. The outcome of the chip war no longer depends on the nanometer numbers of the lithography machine, but on the quantum leap of innovative thinking. ASML's 600 lithography machines will eventually become a footnote in the history of science and technology, and the real protagonist is writing the next miracle in the laboratory in Zhongjiang, Shanghai. In short, ASML has poured 600 DUV lithography machines into the Chinese market, triggering changes in the global semiconductor landscape. Chinese engineers use multiple exposure technology to break through physical limits, and ASML faces competitive pressure. The speed of China's chip industry evolution rewrites the rules of the game, and future success depends on innovative thinking.